Hello friends, welcome to this video, and in today's video we'll be discussing about finding the logarithm of a given number n to the base b. We'll be seeing both iterative and recursive way of solving this, and the algorithm used in both the methods will be a similar one. The idea will be the same. So first let me explain you the idea using an example. So consider this example wherein I have to find log base 2 of 16, and which is 4, because 2 to the power of 4 is 16. Now the algorithm, how it is implemented is, we will go in a reverse way of dividing the given number n with the base till we reach a point where we end up dividing the base by itself. Okay, so that is the point where you end up, because if you go further, if the numerator uh, if the numerator over here becomes less than the base itself, you will always end up in a value of 0. So that is not what you want. You will only need to want a value where you reach the base, because if you go in a forward direction from here, you have to multiply 2 4 times with itself to end up getting 16. So in a reverse way, if you go, you will end up getting the base again. So we will go in a reverse way, and while going in the reverse way, we'll just keep track of how many divisions we are doing to end up in the base. So that will give me the answer. So my termination condition of the loop is n is greater than b minus 1. This is both the termination condition of the loop as well as the recursion also. So let's see this. So for the very first time, n is 16 and base is 2, and 2 minus 1 is 1, so 16 is greater than 1. So I will carry out my division. This is my first division, and then I will get the value 8, which will be my new n. The divisions occurred so far is 1. And then I will carry out my second iteration, because the termination condition is still not met. So I will divide 8 by 2. I will get my new n as 4. Now the number of divisions so far is updated to 2. Then I will check the termination condition, that is the new value 4, whether it is greater than 1. It still doesn't meet the condition, so I will carry out my third iteration. So I will divide 4 by 2 again, which will end up in the result 2, and that is my newly updated n as well. Now the number of divisions occurred so far is 3, so I will update the value to 3. And then again I will check the condition whether n is greater than b minus 1. So 2 is greater than 1. The condition is not met yet, so I will carry out another division, that is 2 by 2, which will end up in the result as 1. So that is my new n value 1, and the number of divisions occurred so far is 4. So the number of divisions occurred in order to reach the base value as n is 4, right? So this is my terminating condition, because if you see now n is 1 and 1 is not greater than 2 minus 1, 1. 1 is not greater than 1, so I will terminate my loop. So I will stop, and then I will return the number of divisions occurred so far. So yeah, that you can see is my answer as well. Let's look at both the iterative and recursive method code. So this is my code wherein I have written two methods. One is for recursive method and the other is for the iterative method. In the recursive method, the base case becomes this condition, and that is n is greater than b minus 1, and the same statement becomes my termination condition in the iteration as well. And I am going to carry out this division process recursively. This is the division process. Recursively, I am going to carry out till this base case is met, and if this base case is met, I am going to return 0, or else I am going to return 1 plus the recursive condition itself, because this one will keep track of my divisions occurred so far. So each recursive call will incur a division, so I will keep on adding it to my recursion stack. And in the iterative method, the same statement is used, the termination condition you can see here, and the result, I've taken a variable result, and I will keep on appending to that result a value 1, or else I'll be implementing that value. as and when I perform a division operation of n by b till I met this condition, and then finally I will return the result. So you can see this is a very simple method, and both of them have the time complexity of big O of log n, where the base is b, so it is big O of log to the base b of n, and the auxiliary space complexity is big O of 1 if the stack space is not considered in the case of recursive method, and in the iterative method also it is big O of 1 because we are not using any extra space to carry out our algorithm. And in case if in the recursive method, if you consider the stack space, then it is big O of log n to the base b. And this is my main method where I'm just printing the result of the example we have just seen. So let's run this and check the output. So using my recursion, I've got the answer as 4, and using my iterative method also I've got the answer as 4. So yeah, that's all for this video. Thanks for watching.